So check about this architecture. Okay, so when we're talking about system, there are normally at least 3 types of system. So today I only talk about centralized and distributed because we learning about distributed system, but there is another system called decentralized. So centralized means we have only one server and every client access to that server. So if the server down, it is a single point of failure. But decentralized means we have several servers, for example, like 1, 2, 3, 4, 5. So if one server down, it might down here, but the other client of this region can access, but the client here cannot access. So that we call decentralized system. But for the distributed system, which means no client, no server, all the system are at the same level. We call it peer-to-peer systems, distributed system, okay? So when your system is very small, normally you may consider to choosing centralized system because why? Because of the advantage of the centralized system is easy to control, easy to update, you easy to develop your software. Okay, but when you move from one system to another system, the complexity is getting harder and harder. Even the management, the development, the management of the infrastructure is very hard. So the short answer is when your system is small in small scale, centralized is the best choice. You don't need to go to decentralized or distributed. Okay.
Okay.
Understand?
Oh, just sure.
អូខេអញ្ចឹងមិញគ្នាយើងសួរថាតើពេលណាយើងប្រើ centralized system ពេលដែល system យើងទូចអត់សូវមានអ្នកប្រើច្រើនអ្នកប្រើល្មមល្មមតើនេះព្រោះអីធម្មតាទូចហ្នឹងវាមិនមែនទូចណាស់ណាឯងព្រោះ MySQL អីក៏ទុកបានរាប់ពាន់រាប់ម៉ឺន user អីដែរលុះត្រាតែ user ហ្នឹងវាច្រើនពេកដល់លានដល់អីហ្នឹងទៅបានភាគច្រើនគេ consider ធ្វើឲ្យ system ហ្នឹងវាមានកាន់តែ server ច្រើន database ច្រើនទៅដើម្បីទប់ទល់ជាមួយនឹង performance របស់ system កុំឲ្យវា slow ឬមួយក៏កុំឲ្យវា go down អញ្ចឹងទៅអូខេ Any other question? So you need to understand why people want to move to the decentralized or distributed system. Otherwise, we don't need to go. Okay. If you can't find the answer, how should you go? You don't need to go. Just centralized system is very good because why? Very easy. Okay. When you choose to be decentralized or distributed, your life will be harder. Okay. But it also has a benefit, pro and con, the same thing. Okay. So now maybe we understand the centralized system. We can move another one to the motivation why people want to change. So here you can see some disadvantage of the centralized system, but there is another reason that people want to move to the distributed system. So the first one is scale up. So when, as I said, when your system getting more and more user, need more feature, your system need to scale up, like scale up in terms of physical, like a RAM or hard disk or performance, or scale in terms of incoming request. We need to update our system, okay? And then the other reason is availability. So people can say these are the same meaning, like availability, reliability, or minimize downtime, which means that your service is running 24 hours per 24 hours, 7 days per 7 days. So when your system is down a little bit, the company may lose some money. So that's why they want to have, for example, like not one server, but 2 servers. So if one server is down, another one server is up, okay? But if the 2 server is down, they may have some downtime, but they want to minimize the downtime, which means that for 1 month, 1 year, 1 week, they want to cut down the downtime of their system so that their system may seems like running all the time, okay? For example, like some company within 1 year their system down for 2 hours, something like that in average, or like 10 hours. So they want to minimize that downtime. So that's why we call it minimize downtime, or sometimes we just call it availability, so that the system is available all the time, okay? Or the system is very reliable, which means the system is not down. The system is very trustful, very reliable. So that kind of property that people want to change or want to update their system. អញ្ចឹងតើណាយល់អត់សិស្សខ្មែរព្រោះភាគច្រើនខ្ញុំនិយាយអង់គ្លេសហ្នឹងខៃលោអត់សូវយល់អញ្ចឹងថាហេតុអីបានយើងចង់ទៅ distributed system ហ្នឹងដោយសារតែអីគេដោយសារតែយើងចង់ឲ្យ system ហ្នឹងវា available ហ្នឹងមានន័យថាវាអីគេភាសាខ្មែរ available បានន័យថាវាមានបានន័យថាវាបំរើសេវាកម្មរហូតវាអត់មានដាច់ទេអាហ្នឹង reliable available reliable ក៏ដូចគ្នាដែរមានន័យថាវាគួរជឿជាក់អា system ហ្នឹងជឿជាក់បានន័យថាប្រើវាពេលណាគឺបានពេលហ្នឹងអត់មានប្រើអត់បានទេអូខេឬមួយក៏ minimize downtime ហ្នឹងមានន័យថាកាត់បន្ថយអាភាព error ឬមួយក៏ភាព go down របស់វាហ្នឹងឃើញទេ and the third property that we want to go to distributed system is a multi-party. So normally before people always work alone in isolate, but in today's world like a social media, people want to interact with each other. Even the company, when they create a company, they don't want to be silent or to work to build their business model, a single business model. They want to cooperate with their supplier, with their client, with their partner, something like that. So that's why when they want to interact with each other, those kind of system also need a distributed way of communication, not centralized. Otherwise, the other system cannot talk to the other system. Okay, so in that kind of environment, people also want to build the distributed system. And then the word interoperability mean uh, that we have a multiple system that want to talk to each other. Their system could use a different kind of technology, different kind of machine, but they can talk to each other. Okay, even different kind of programming language. Okay, so that are the trend that we want to change to the distributed system. And the other one is the trust, which means transparency and auditability. So when we work with the multiple player, multiple organization, those companies don't trust each other. So if they don't trust each other, they need something that could build the trust for them. Okay, so normally they choose the third party, but in the distributed system allow them to not using third party, only them between them two party, and then the technology itself provide the transparency and auditability for them. Okay, and then we will discuss more when we talk about the distributed system and blockchain technology. So how do the distributed system build trust, build transparency, and then we can have an audit, which means that we can see what change, what is not change, and who change it, and how to not allow someone to modify something in the system easily. Okay, so that are the motivation that we want to change to the distributed system. Not only the centralized system is bad, but there are some other objectives that people want to change. Your question? ចឹងបានន័យថាចំណុចដែលយើងចង់ផ្លាស់ប្ដូរពី centralized ទៅ distributed system ហ្នឹងវាមិនមែនតែ centralized អាក្រក់មួយទេគឺវាមានអាផ្សេងទៀតដូចជានៅពេលដែលមនុស្សឬមួយក៏អង្គការឬមួយក៏ក្រុមហ៊ុនច្រើនធ្វើការជាមួយគ្នា system តែមួយក៏អាចបំរើអា use case បែបហ្នឹងឯងចឹងវាត្រូវការ system ដែលវាលក្ខណៈបែប decentralized ឬមួយក៏ distributed បានអាចឲ្យក្រុមហ៊ុនច្រើនហ្នឹងធ្វើការជាមួយគ្នាកើតអូខេបើមិនអញ្ចឹងទេគឺវា lost trust វាអត់មាន trust ហើយទៅបានន័យថាក្រុមហ៊ុនមួយត្រូវជឿលើក្រុមហ៊ុនមួយទៀត 100% ហ្មងតោះណាបានធ្វើការមួយគ្នាកើតក៏ប៉ុន្តែបើ distributed system បាច់ទេគឺរៀងខ្លួនគ្រប់គ្រងរៀងខ្លួន question any question understand yes no okay
Yes teacher
តោះ yes ឆ្លើយដាក់ yes ក្នុងនេះមួយណាគេខ្លះ yes ណាគេខ្លះ no យល់អត់ប៉ុណ្ណឹងកែលោបើវីដេអូចោលហើយតើណាបាត់អត់ស្ដាប់តោះណាគេយល់ដាក់ yes នៅនេះមួយមក3 4នាក់មក understand what is the distributed system, what is the centralized system, why do we need to change to the distributed system ណាត់ឆឹងចឹងកុំព្យូទ័រអត់មាន keyboard ទេ Okay, so if someone understand, please say type yes in the chat room so that I can see. Otherwise, I don't know who understand, who doesn't understand. Okay. 20នាក់ yes បាន3នាក់7 10នាក់ទៀតដេក Okay. Okay, so now I can see that some of you are listening. So we can move on to the real distributed system. So as I said, there are centralized system, decentralized system, and distributed system. Today I don't talk about the decentralized system. I just compare the centralized and distributed system. So distributed system, which means there are multiple server, multiple machine. So everything which is multiple, which means more than 2, we call it distributed system. Okay. So in this case, we don't have only one single server, but we have a lot. So a lot, which means more than 2, 3, 4, 5, even 1,000, even in, for example, like blockchain, there are million of computer, okay, million of computer online. Every single computer, even laptop, even a single processing machine, for example, it is not laptop. It just has a CPU and then RAM and then a GPU, something like that. It could be a computers. That's why in the definition, we said computer, okay, like a distributed system is a collection of independent computer. But now it doesn't mean always computer. Some machine you do only have CPU and RAM and something like that. It could be it could join the network also, the distributed network also. So in the distributed system, you have multiple network. So for example, like if one server down, you can access to the other server. So your system is always up. We can say that it is available all the time, okay, 24 hours. But normally when we change from some system to another system, or when we change from one technology to another technology, people always talking that those technology are the best, like the best, the bullet, we call it the silver bullet, something like that. When you use it, you can solve all the problem, okay? So in reality, it doesn't mean like that. So that's why here I don't say it is an advantage, I said it is a myth. So what is a myth mean? Myth mean people are talking like that, but in reality, it could be yes, it could be no. Okay, that's why I said it is a myth. It is not a reality. So people say that distributed system are very high performance. Okay, so when you use this centralized system, is very slow. Distributed system is very high performance. The speed is very fast, like fast speed. Or for example, like centralized system is not secure, and then the distributed system is very secure. It's more secure. Okay. Or sometimes people said that the centralized system doesn't scale well, but the distributed system is very scale. So when people are talking like that, it could be true, but it could not be true. Okay, because inside one system, as I said, there is a pro and con. Sometimes there's a advantage and disadvantage. So when we claim like this, you should have some proof. Because for example, like I give an example like Bitcoin. Bitcoin is a blockchain, it's a distributed system, and the speed is very slow. Okay, so people said that okay, when you move from one computer to 10 computer to 1,000 computer, it will increase the speed. Okay, but it doesn't true. Like Bitcoin, the speed is very slow. Okay, so that's why I said it is a myth. So when you see that people are talking like that, it's just like a marketing strategy. Okay, but if you really learn deeply about the system, you will understand where is the speed is fast and why it is slow. So which part is secure and which part is not secure. Okay, so that's why this question are yes and no question, not fully yes or not fully no. Okay, vô lớp nẹp xì, vô nhôm vậy á. Hello, vô lớp. Ngày đang dạy ông lại hiện trận thì chừng
អ gesture
ហ្នឹងហើយខ្ញុំចង់បញ្ជាក់ថានៅពេលដែលយើងបដូរពី system មួយទៅ system មួយភាគច្រើនអ្នកដែលស្រឡាញ់ឧទាហរណ៍ថាអ្នកដែលស្អប់ centralized system ហើយស្រឡាញ់អា distributed system តែងតែបន្ទោសថាអា centralized system ហ្នឹងវាអត់ secure ទេវា slow ណាស់វាអីយ៉ាងទៅវាអត់ scale ទេសូមនាំគ្នា move មក distributed system មកដែលនៅពេលដែលកុំព្យូទ័រច្រើនហ្នឹងគឺ speed វាលឿនវាមហា secure វា scale វាអីយ៉ាងទៅអូខេអញ្ចឹងអ្វីដែលគេនិយាយហ្នឹងខ្ញុំដាក់ពាក្យថា mythology ហ្នឹងមានន័យថាវាគ្រាន់តែជាដូចរឿងនិទានអញ្ចឹងណាមានន័យថាអ្វីដែលគេនិយាយហ្នឹងវាអាចពិតឬមិនពិតក៏តែយើងកុំជឿគេក្នុងនាមជាអ្នក technology កុំជឿគេបានន័យថាអាពាក្យអស់ហ្នឹងគឺសុទ្ធតែពាក្យគេហៅ claim ទេបានន័យថានិយាយដោយប្រយោលតែអត់មានអីអះអាងទេដោយសារអីដោយសារតែការពិតគឺវាមិនមែនអញ្ចឹងទាំងស្រុងទេព្រោះអី system អីក៏ដោយដូចខ្ញុំនិយាយអញ្ចឹងមិនថា centralized system មិនថា distributed system វាមានចំណុចល្អចំណុចអាក្រក់រៀងខ្លួនអញ្ចឹងឧទាហរណ៍ថាគេថា move មក distributed system មក speed លឿនហេតុអីបាន speed លឿន Bitcoin ជា distributed system ក៏តែ speed មហា slow តោះណា slow ឡើងចង់លែងមាន user ចង់ប្រើហ្មងអត់ចង់ប្រើហ្មងយល់អត់អញ្ចឹងបានន័យថាអ្វីដែលគេនិយាយហ្នឹងគឺយើងកុំជឿគេតោះតែយើងសិក្សាថាផ្នែកណាមួយដែលវាលឿនផ្នែកណាមួយដែលវា slow ផ្នែកណាមួយដែលវា secure ផ្នែកណាមួយដែលវាអត់ secure តោះណាមិនមែនបានន័យថា system មួយល្អជាង system មួយទៀតទេអូខេ so here just I would like to reinforce what we have learned like when people are talking about something you need evidence you need proof because otherwise those are just a marketing term okay it is not real so every system has pro and con okay so now we can move on like now you know that why we want to move to the distributed system and then the distributed system could provide like what multi-party or reliable we can scale it up something like that but normally it is very complicated and then we need to understand more about it it doesn't mean that when we move to distributed system it's very secure or very scalable or something like that okay so now let's see this architecture so here from one server, now we have 3 server, which means we already scale our server a little bit, okay? But you can see that all the server are linked to a single database. So in this kind of system, normally we can break our system into several parts, for example, like front end or client side, like back end or server side, or sometimes they have something between, we call it proxy or whatever, and then we have a storage side called database. So in this case, you can see that this architecture has scaled a little bit about the server, but for the database, it's still centralized. So whatever the disadvantage of the centralized system is already inherited here in the single database. So for example, like you have one database, and when your database is have some error or maybe some hacker hack it, okay? So it is still a single point of failure, okay? So whenever you see something which is one, it always has a consequence of the disadvantage here, okay? Single point of failure, management of overhead, can scale, something like that, okay? So now even if your server has a lot, but your storage is still one, so which means that you have some kind of a distributed system, but your storage is still centralized, okay? So here you can see you have centralized database, and then some like a multiple server. So your database is still a single point of failure, management of overhead, or something like that. So when we talk about distributed aspect, not distributed system, distributed aspect, we have a different kind of place. For example, like server, storage, or communication, or whatever. So it doesn't mean that when you scale your computer here, it become a fully distributed system. No, because your database is still centralized. Okay. យល់ចំណុចហ្នឹងឯងយល់ចំណុចដែលខ្ញុំនិយាយអត់
អត់ទាន់ clear ច្រើន
អូខេអត់ទាន់ clear និយាយខ្មែរម្ដងអញ្ចឹងមានន័យថាយើងនិយាយមិញយើងថាបើសិនជា server កុំព្យូទ័រតែមួយហ្នឹងយើងហៅវា centralize តទៅពេលឥឡូវគេ move អា server ហ្នឹងមក3បានន័យថា server ហ្នឹងឥឡូវមិនមែនមានមួយមានដល់ទៅ3អញ្ចឹងមានដល់ទៅ3យើងឃើញថាអាហ្នឹងយើងហៅវាថា distributed system ហើយកុំតែពេលដែលត្រឡប់មកមើលអា database របស់អា system ទាំងមូលហ្នឹងវិញគឺ store នៅកន្លែងតែមួយឯងមានន័យថាអា server នេះក៏ access មក database មួយនេះ server នេះក៏ access មក database មួយនេះហើយ server នេះក៏ access មក database មួយនេះដែរអញ្ចឹងមានន័យថា system ហ្នឹងវា distributed តែ server តែចំនួនម៉ាស៊ីនទេតែតទៅពេលអា storage វិញនៅតែមួយដដែលទេនៅតែ single ដដែលទេអញ្ចឹងបើសិនជាបើស្អីក៏ដោយឲ្យតែយើងឃើញ single មិនថាវាជា database មិនថាវាជា server មិនថាវាជាអីឲ្យតែ single គឺវានឹងមានបញ្ហាមួយតាក់ទងជាមួយនឹង disadvantage របស់ single នេះ disadvantage ផងបានន័យថាអ្វីដែលជា disadvantage របស់មួយគឺគេវាគឺជា single point of failure មានន័យថាបើសិនជាមួយនឹង go down ឬមួយក៏មានបញ្ហាឬមួយក៏ crash ឬមួយក៏ error ឬមួយក៏ hacker លួចយកគឺ system ទាំងមូលហ្នឹងគឺ down ហើយតោះណាឧទាហរណ៍ថាឥឡូវកន្លែងនេះពេលដែល hacker យក database ហ្នឹងទៅបាត់ឬមួយក៏ធ្វើឲ្យ database ហ្នឹងញ៉ៃសួរថា server 3ហ្នឹង access ទៅកើតអត់មិនអត់ទាំងអស់អញ្ចឹងដល់មួយ system ហ្នឹងវាមិន down តទៅពេល system ហ្នឹង down វាមិនអត់ available តោះណាអញ្ចឹងបានន័យថាទោះបីជា system ហ្នឹងវាមាន server ច្រើនក៏ដោយតែយើងឃើញស្អីគេដែលនៅសល់តែមួយហ្នឹងវានៅតែ single point of failure ដដែលទេគ្រាន់តែ system ហ្នឹងវាបានផ្លាស់ប្ដូរពីកុំព្យូទ័រមួយទៅកុំព្យូទ័រច្រើនតែ database វានៅតែមួយដដែលអញ្ចឹងវានឹងមានបញ្ហាតាក់ទងជាមួយនឹង centralized disadvantage របស់ centralized ដដែលយល់អត់ប៉ុណ្ណឹងធម្មតាយើងចំណាំមើលថាឲ្យតែមានមួយគឺច្បាស់ជា single point of failure ហើយតោះណាserver មួយ single point of failure server តទៅពេល database 1 single point of failure of the database when the database has been hacked or some error happen all the system is down you have lost your availability your client cannot access to the service because your database is broken or have been changed or has been hacked so that is still a single point of failure okay it is not fully a distributed system because you have some kind of component of your system is still centralized តើអត់យល់នៅ
យល់ទេ
អូខេអញ្ចឹងបានន័យថាកុំព្យូទ័រច្រើនមែនតែតទៅពេល database មួយវានៅតែ single ដដែលហ្នឹងវានៅតែ centralized database ដដែលហ្នឹង Okay, so now we have moved our database to a lot, okay, not one but a lot. So now you can see that your system has 3 server and 3 database. So when your server, when client access to this server, it can go to this database. Normally, this server can also access to the database. Okay, it can access to many things because the distributed system is mean that there is a lot of link and communication. Okay, in this case, I just write like this. So for example, like now this one server is down, this client can, when they access to this server is down, they can access to this server and then they can go to this database to access the data. So the service is still available. That is the advantage of the distributed system, and then it provide the availability property. Okay, so when one system down, you can go to the system. When this system down, the client could go to this system and then they still can go to the database. Okay, understand? And then all the database has the same data. So that we call distributed system. Sometimes the database is scale. For example, like when the company is getting bigger, they store their user here. They store their, for example, like if we do the student management. So now all the student is here, all the scoring is here, all the timetable is here. So that is not the distributed system. It's just they just separate the database so that the database server will not be more overhead of the request. So when the request is talking about a user, they will request to this database. But when the request is talking about like scoring or timetable, they will request to another database. So that is some kind of distributed, but not distributed system. It's just like a distributed way of separating the data. But the distributed system means all the database are the same. For example, like everything you can see in this database, you can also see in this database. So that is the real distributed system. Okay, so you when you see people develop some application or project, you may see this kind of two aspect. For example, like when you have multiple database, does your database has the same data or different data? Okay, so if your database has different data, it is not a distributed system. It just they separate the data, but it is still a single data. For example, like all the user is here, all the timetable is here, but when this database is go down, you lose all your user. So that is still a single point of failure. Okay, but if your data is separate in, if this database and this database are the same, so when you lose one database, you can have another database. So you still available. Your database is still available. Okay, Don. Vô là vô.
Just teacher.
Ta hả lỡ nà cái vô chui bỏ sai mình mới nhung vậy thôi mày. So if you understand, you can repeat what I have said. The two aspects of the database. You can talk in English or in Khmer, up to you. Okay. So anyone volunteer, so that I can understand like you understand or not.
Just teacher for the distributed system, there are two kinds of database that they store. The first one that they separate the data. Also, that kind of system is not fully distributed. Or for another one is or they have multiple database and all the database or like they store the same data. So it can call a fully distributed system.
Okay. So it's true, but the first one is not really a distributed system, okay? Because that they just distributed the table, the user, like there are multiple table in the database, and in order to minimize the performance, maximize the performance of the database, they separate their table, like some table storing in this database and another table in storing database. So they just separate the table, but the system is still not distributed. Because why? Because when they lose their first database, all the table in that database are gone. Okay, so they lost everything, and then when people request for the user database, they cannot access because the data is down. So that is not really a distributed system. That is just a way of distributed some data to different database. So the real distributed system, which means that all the database are the same. So when you access to this database and this database, you can see that the data in each database are all the same. So that kind of system, we call it distributed system. Okay. And there's also another technique that we can split the data. For example, like when you have one single data, you can split to multiple database. And then even one database is lost, you can recover that data. So that is also another aspect of distributed system, and we will talk it later. Okay. Because it is more advanced, but we will talk it later. So now you need to understand that when we separate data into many database, it is not a really distributed system. But when the database store the same data all in every database, that is called distributed system. Okay, because we replicate our data. So now let's talk about the characteristic of the distributed system. What kind of system we call it distributed system? Okay, so the distributed system, there is a property called independent or concurrency, which means that all the system are working in parallel and independent. Okay, so for example, like you have different kind of machine or different kind of database. So all the database, they work their own way. The server, they work their own way. Okay, like this server, for example, like you have three server and three server located at different location, and then the way it is working is very independent. So it is not depend on each other. It is concurrency, which means it is work in parallel, and then it is independent failure, which means that sometimes this server fail, sometimes this server fail, and sometimes this server fail. And then whenever they fail, we don't know. So that's why we call it independent. Okay, because sometimes we lost electricity here, sometimes the hacker come and hack this server. So that is the property that we call independent and concurrency. Okay. អញ្ចឹងនៅពេលដែលយើងមាន server ច្រើនអា property របស់វាយើងនិយាយថាវា independent មិនថាវាអត់មានតាក់ទងគ្នាទេគឺរឿងរៀងៗខ្លួន server ណានៅកន្លែងណានៅបន្ទប់ណានៅរៀងៗខ្លួន concurrency បានន័យថាវាធ្វើការក្នុងពេលជាមួយគ្នាក្នុងពេល parallel តើដល់ពេលវាខូចក៏ខូចរៀងខ្លួនដែរបានន័យថាជួនកាលអាកុំព្យូទ័រនេះដាច់ភ្លើងជួនកាលកុំព្យូទ័រនេះត្រូវគេ hack អីហ្នឹងទៅតោះណាអញ្ចឹងអាហ្នឹងឯងគេហៅ characteristic for distributed system. Okay. So the first characteristic of distributed system is all the machines are working independently and concurrency. And then when they fail independent also. Okay. The other problem we call it partitioning. So partition, which means that, for example, like your computer are located at different region. So now, for example, like in China, people are blocking the firewall or something like that. And then this computer now cannot talk to these two computers. So that we call it a network partition, which means that these two network can communicate with each other, but these two machines cannot communicate to another server. So we have some kind of partitioning. Okay. So these are the second property of the distributed system. Because if it locate at the same place, it's okay. But if it locate at different region, different country, it may have some partitioning occur. Okay. អញ្ចឹងអា property ទី2យើងហៅវាថា partitioning ហ្នឹងបានន័យថាវាបែងចែក region គ្នាឧទាហរណ៍ថាកុំព្យូទ័រមួយនៅចិនមួយនៅខ្មែរមួយនៅអាមេរិកអញ្ចឹងទៅស្រាប់តែចិនបិទ firewall មួយអត់ឲ្យកុំព្យូទ័រហ្នឹងsend request ឬមួយក៏ send អីចេញក្រៅកើតទេអញ្ចឹងនាំឲ្យ server ខ្លះវាតាក់ទងគ្នាកើតតែ server ខ្លះតាក់ទងអត់កើតអញ្ចឹងនៅពេលដែលវាតាក់ទងអត់កើតហ្នឹងឯងអាលក្ខណៈបែបហ្នឹងឯងគេឲ្យឈ្មោះថា partitioning network partition. Okay. វាបែងចែក region គ្នា So the third property is about replication. So for example, like if you have one data here, you need to back up, you need to copy to another place, and then this data here you need to copy to another place. So this kind of property we call it replication. Okay. So when you read the document, you will see a lot of log replication term. Okay. Log means just a database. Okay. So replication, log replication, which means you replicate, duplicate, triplicate your data to many places. Okay. And the other one is no global clock, which means all the system has their own clock. And then they don't know when, for example, like now we are 7:47. Okay. Let's look at your computer. So now what time is your computer? For example, like me, 7:48. So what is the time in your computer? ចឹងឥឡូវខ្ញុំម៉ោង 7:48 នេះចុះកុំព្យូទ័រយើងម៉ោងប៉ុន្មានសាកមើល What is the time in your personal computer?
Exactly the same.
How about the other?
Oh, the same, teacher.
Okay, so do you think that it's really the same? So maybe it is the same because of the hour and then the minute like 7:48. Okay, but sometimes when you go to second, it might be different. Okay. And sometimes, for example, like some people, they change their clock in their machine. Okay. So that means that the two different machines could have different time. Okay. Even a different time zone. For example, like we are in Cambodia, 7 o'clock, but if you are in France or in United States, the time may be different. Okay. Because we are in the different time zone. So that's why the property of the distributed system is all the system don't have the same time. We call it no global clock. Okay, that's why timing is also the problem in the distributed system. People need to find a way that how should all the computer system see exactly when in this moment what time is it? Okay, that is the problem also in the distributed system because they located at different place, so they don't have the same time. Okay. So now do you understand that the characteristic of the distributed system, like what type of system we call it distributed system? Okay, so the system which has a lot of computer, a lot of we call it node, work independently, concurrency, independent failure. Sometimes it has partitioning, and then the data replicate a lot of place, and then they don't have the global clock. Those kind of system we call it distributed system. យល់ទេបានន័យថា distributed system ហ្នឹងវាមានលក្ខណៈសម្បត្តិបែបហ្នឹងមានកុំព្យូទ័រច្រើនកន្លែងពេលខ្លះវាដាច់វាតាក់ទងគ្នាអត់កើតហើយអា data ហ្នឹងវាត្រូវ copy ឲ្យច្រើនកន្លែងបន្តមកទៀតបើនិយាយពីម៉ោងវិញគឺវាអត់មានម៉ោងតែមួយទេគឺ no global clock បានន័យថាកុំព្យូទ័រមួយម៉ោងរៀងខ្លួនអត់ដឹងថាណាម៉ោងប៉ុន្មានទេតោះនេះវាអាចខុសគ្នាពី second ឬមួយក៏អីហ្នឹងទៅប្រហែល second ហើយបើថាកុំព្យូទ័រហ្នឹងនៅប្រទេសខុសគ្នាទៀតខុស time zone បណ្ដោយដូចយើងម៉ោង7ព្រឹកអញ្ចឹងគេម៉ោង7យប់អីហ្នឹងទៅតោះណា Okay, question. Any question about this? Clear about the characteristic of the distributed system?ទៅទៀត Okay, so when we talk about distributed system, people always talk about the CAP theorem. So CAP stand for what? C stand for consistency, A stand for availability, and then P normally stand for partition tolerance. So I forget to type tolerance. I only type partition. Okay. So P stand for partition tolerance. So CAP theory is talking about three things: consistency, availability, and partition tolerance. So what is consistency? Anybody can tell me what is consistency? តើ consistency នឹងចង់និយាយពីអីមានអ្នកគេដឹងអត់ដឹង search Google មកខ្វាច់មក What is consistency? So now I'm asking the question, what is consistency? What is availability? What is partition tolerance? So how could you answer those questions? Who can answer the question? What is consistency? You can talk or you can type here. It's okay. What is consistency? តើ consistency ជាអី Consistency មកពី consistent. So what is consistency? Consistent នៅសាធាតោះមានអ្នកគេឆ្លើយបានទេតើ consistency នឹងចង់និយាយពីអីបើអត់ដឹង search Google មកខ្វាច់មកបកជាខ្មែរមកខ្វាច់មកអញ្ចឹងបើកុំព្យូទ័រឲ្យទៅបាយស្រូវបាត់អស់ហើយ Hello anyone Okay, if you don't know what is consistency, come to Google. So when you don't know something, these are the easy way, okay? The definition of consistency, which means signals or something stay the same or is done in the same way or look the same, okay? So normally signals is not really the computer meaning, but these are the meaning, some meaning related to computer. So something which is the same or like look the same or something same, we call it consistent, okay? Consistency. Like another definition, like a harmonious uniformity or agree among the thing or part, okay? So consistency in computer, like what is the in computer? So consistency in computer, what are the consistency? Sometimes they call it correctness. In the database system refer to the requirement that any given database transaction must change affect the data only allow the way any data written in the database must valid according to all the defined rule, including constraints. Oh, this is very complicated. Okay, so sometimes they call it agreement or harmony. So normally the first definition is good, like something which is the same, okay, which is an agreement. So I can maybe I can give an example. Okay. So for example, now we have two database. Okay. Now we have two database, and then we have one user. Okay, and that user is write something to the database. Okay. For example, like we can write x equal to 2. Okay. So now when some user want to write something to the database, no, so now x is equal to 2. And then the database, they replicate to another database. So you see that the distributed system has a replicated property. So now x equal to 2 is also here. Okay. So when this database has x equal to 2 and then this one is x is equal to 2, we call this one is consistent. Okay. So for example, like now the user, they change the data. So they change modify x is equal to 3. Okay. So now when this one is modified to 3, but the other database has not changed yet. And then another user want to read the data. So when this user read from this database and another user read from this database, so what do this user see? For example, we can say this user is A, this one is B, and then this one is C. So now user B, what is the number, the value of the variable X for user B? ចឹងឧទាហរណ៍ថាយើងមាន database 2 ចឹងណាហើយ user មួយហ្នឹងគាត់តែ say ថា x ស្មើនឹង 2 ហើយ save ទុកក្នុង database មួយនេះបន្តមកទៀតគឺធម្មតា distributed system វា replicate ហើយអញ្ចឹងអា x ស្មើ 2 ហ្នឹងវានៅនេះផងវានៅនេះផងតទៅពេលក្រោយមកទៀតអា user ហ្នឹងវាបដូរពី 2 ទៅ 3 អញ្ចឹងអាខាងលើនេះ 3 អាខាងក្រោមនេះ 2 ព្រោះអាខាងក្រោមនេះវាអត់ទាន់បាន update ទេតែនៅពេលដែលវាមិនទាន់បាន update ហ្នឹងមាន user ផ្សេងទៀតគេ access មក database ហ្នឹងស្រាប់អានេះ access មក database ខាងលើអាមួយនេះ access មក database ខាងក្រោមអញ្ចឹងសួរថា user ខាងលើនេះឃើញ x ស្មើប៉ុន្មាន Yeah, user B, what are the value x that user B see?
Number 3.
Okay, then user B ឃើញ x ស្មើនឹង 3, okay? How about user C? When they access and then they retrieve the data from this database. So what is the value of the x? X ស្មើប៉ុន្មាននេះ So how about user C? What are the value of the variable x? Ở đó này, ở đằng thấy x ស្មើប៉ុន្មាននេះ Hello. ចម្លើយវានៅ2 8គឺ2 7គឺ3 Hello. X ស្មើប៉ុន្មានសុំម្នាក់មើល 50% សោះហ្នឹងចម្លើយមានតែ2ទេ
For user C, x equal to
user C ឬមួយក៏ B
C.
ហ៎
User C, x equal to.
Okay, so when the user A override the variable x equal to 3, but the data has not replicated yet because maybe the server is still has a lot of time, and then maybe the network is partitioning, or maybe the update request is not coming to the second database yet. So in this case, when the user want to connect to the database, and when it connect to this one, this machine or this database, it will see the value 3. But when the other user connect to this database and the action is not updated yet, they will see the result x is equal to 2. So in this case, we say that the system is not or the database is not consistent. Okay, not consistent. If it is consistent, when the user, no matter which database or which computer it is a request, the answer must be the same. So if the answer is the same, we say it is consistent. Okay, we say it consistent. But if the result is not the same in this case, you see that one is C number 3, one is C number 2. So in this case, we call it not consistent because the data is not the same. For example, in Facebook, when you have one very popular star, for example, like Prip Sabat is the singer of Cambodia. So when he posts one comment and then many people go to like it, okay? So when you want to go to like and you click on one like, you see that your computer like 2000, for example, like 4 people are liking this comment. But when the other people in another place, when they go to see Privsavat, sometimes they see like 2007, something like that. Okay. So why you see different number? Because when you access to this data, you retrieve from one database. For example, you are in Cambodia, you retrieve the database from Singapore or something like that. And when people are from United States, they access to the database in United States. So sometimes you may see that your result is not the same. Like you can see that, oh, there are 2004 people like the post, but the other people see 2007. So we can see that this data is not consistent. Okay, understand? យល់ទេអាពាក្យ consistent ហ្នឹង consistent ហ្នឹងមានន័យថាបើសិនជា data ហ្នឹងវានៅច្រើនកន្លែងមែនតែយើង access ទៅពីកន្លែងណាក៏ដោយគឺឃើញ data ដូចគ្នាទាំងអស់អាហ្នឹងគេហៅ consistent ហើយតោះណាក៏តែបើយើង access ទៅអាមួយឃើញចេះអាមួយឃើញផ្សេងទៀតអាហ្នឹងយើងហៅ odd consistent ទេ not consistent. Okay, understand? យល់ពាក្យ consistent ហ្នឹងនៅ hello hello ឃ្លានបាយឯងកូនសិស្សសួរអត់សូវឆ្លើយអញ្ចឹងយល់នៅយល់ពាក្យ consistent ហ្នឹងនៅនឹងធ្វើមិនទេឲ្យព្រះអង្គប្រនាងព្រមនិយាយ
Yes, teacher.
ងាត់ឆឹងដោះ yes មួយអ្នកផ្សេងទៀត yes ឬមួយក៏ no យល់អត់យល់ថា consistent ហ្នឹងមានន័យថាម៉េចអត់
Yes, sir.
Gesture.
អូខេគ្រាន់តែនិយាយក៏អត់ចង់និយាយដែរគ្រូនិយាយម្នាក់ឯងឡើងចង់ស្អកកហើយ Okay, so now if you understand consistent, another word is availability. So this very easy to understand. Available, which means that when you access it always on. For example, if the website, when you go to website 100 times, the website is always available 100 times. Okay. So if it is down, we say that it is not available. Okay. But if you can access to that and it work, we say it is available. Okay. Understand? So CAP theorem, we are talking about 3 things. So one is the consistency, which means the data look the same when you go to everywhere, every computer, every database, the data return the same result. So this is consistency. So availability, which means that when you anytime you access to the system, it always works. So we call it availability. Okay. In opposite, when you access to the system and when it go down, we call it not available. Okay. So we can say consistent, not consistent, available, not available. And then the other one is partition tolerant, which means that when the network has partitioning. So I can see show the figure here. So when we have 5 server and then these 2 server can communicate with each other and these 3 can communicate with each other, but this group of computer cannot talk to this group of computer. In this case, we call it there's some partitioning happening. Okay, but even the partitioning happening, your system is still working. Your system is still provide some service to the user. So in this case, we can say it is a partition tolerant because you can see the word tolerant. Tolerant which mean that whenever there is something happening, but the service is still available. Okay, so we say it is partition tolerant. អញ្ចឹងយល់ពាក្យ partition tolerant នៅ partition មានន័យថាវាបែងចែកជា part បានន័យថាវាមានច្រើន part វាអាច2អាច3អាច4ហ្នឹងទៅអញ្ចឹងកុំព្យូទ័រហ្នឹងវាបែងចែកជាច្រើនក្រុមហើយកុំព្យូទ័រហ្នឹងវានិយាយគ្នាអត់កើតទេវាឆ្លងគ្នាអត់កើតដោយសារវាមានបញ្ហាអីមួយកើតឡើងដែលធ្វើឲ្យវាបែងចែកជា part ហ្នឹង partition ហ្នឹងក៏តែនៅពេលដែលយើងនិយាយអំពី partition tolerant វិញមានន័យថាម៉េចមានន័យថាបើទោះបីជាវាតាក់ទងគ្នាអត់កើតក៏ដោយក៏ user ក៏ service វានៅដើរដែរបានន័យថាបើវា service ធនាគារគឺនៅតែដកលុយដាក់លុយបានធម្មតាបើសិនជាសិស្សនៅតែបើកមើលមេរៀនបានធម្មតាអញ្ចឹងអូខេអញ្ចឹងក្នុងករណីហ្នឹងគេឲ្យឈ្មោះថា partition tolerant ហើយមានន័យថាទោះបីជា partition កើតឡើងក៏ service នៅតែដើរដែរ Okay, so now understand the cap, the meaning of the cap: consistent, available, and partition tolerant. Okay, understand now? So cap theorem is talking about 3 things: consistency, availability, partition tolerant. So first you need to understand what is the meaning of each property. Okay, and after that the cap theory will say that you can choose only 2, not 3. Okay, in the distributed system there is not there's no way that you can have the three property at the same time. So you can choose only two, but you need to give up one thing. So that is the Kepler theorem would like to refer to. តើមិញមានណាគេនិយាយគេមិញមានសំណួរឬមួយក៏មានអីមិញ
មិញខ្ញុំឆ្ងល់ថាបើសិនជាវាមាន partition អញ្ចឹងវាមិនខុសស្គាល់ consistency ចាអញ្ចឹង
បានខ្ញុំហ្នឹងហើយអញ្ចឹងបានខ្ញុំនិយាយថា okay now you have a question. Okay, so one of our friends asking when the network has partitioning, how can they has consistency? Okay, so that's why when we talk about the Kepler theorem, as I said, you can choose only two but not three. Okay, so you can choose between consistency availability but give up partition tolerance, or you can choose consistency partition tolerance but give up availability, or you can choose partition tolerant availability but give up consistency. So your friend is asking if the network is partitioning like this, how can the system has consistency? Okay, so who can answer this question? អញ្ចឹងមិញមិត្តភ័ក្ដិយើងសួរថាបើសិនជាវាមាន network partition អញ្ចឹងធ្វើម៉េចឲ្យវា consistent កើត Anyone can answer? Like now we have 5 server and then the server has partitioning happen. So now you can see that in this 3 CAP you can choose only 2. So now partitioning is happening. Okay, so if partitioning happening, now you can choose between consistency or availability. If you choose availability, you need to give up consistency, but if you choose consistency, you need to give up availability. So now the question is, if the network partitioning is happening, so now P is happening. So which one do you choose? You choose consistency or you choose availability? So the question is, how can we make the system consistent if the network is partitioned? Okay. សំដៅហ្នឹងវារៀង complicated តិចតែខ្ញុំបកជាខ្មែរវិញណា Cap theory ហ្នឹងគឺចង់និយាយពី3ពាក្យនេះហើយទៅគេនិយាយថា Cap theory ហ្នឹងគឺយើងរើសបានតែ2ក្នុងចំណោម3ហ្នឹងរើស2ណាក៏បានដែរតែវាមិនអាច3ហ្នឹងកើតឡើងក្នុងពេលតែមួយបានទេអញ្ចឹងឧទាហរណ៍ថាឥឡូវ network partition កើតឡើងអញ្ចឹងបានថា P នេះវាកើតឡើងហើយអញ្ចឹងអ្វីដែលយើងរើសបានគឺរើសបានរវាង C ហើយនិង A អត់អាចរើសបានទាំងពីរទេតោះណារើស C ត្រូវអត់ A រើស A ត្រូវអត់ C ហើយឥឡូវមិត្តភ័ក្ដិយើងសួរថាចុះបើវា network partition អញ្ចឹងធ្វើម៉េចយើងបាន consistencyចម្លើយគឺថាម៉េច You can choose between two among the three properties. So now you choose one is P. Okay. So now if you want to choose C, what should you do? You want to choose C and P. You want to choose partition and consistency. So what should you do? Anh ấy đốiសំណួរ logic ចឹងណាមានរបស់3តែគេឲ្យយើងរើសតែ2ឯងមិនអាចរើស3បានទេឥឡូវយើងចង់រើស P ហើយនិង C តើយើងត្រូវធ្វើម៉េច So now you choose P because the network already partition and you want also your system to be consistent, so you want to choose C also. So what should you do? What should you do with A? Can you choose A? Can you choose A? So now you choose P and C. Can you choose A again? យល់អត់យល់ខ្ញុំសួរអត់បានន័យថា Cap theory ហ្នឹងគេប្រាប់ថាវាមានរបស់3យ៉ាងហ្នឹងក៏តែយើងអត់អាចរើសបាន3ទេយើងរើសបានតែ2ណាក៏បានដែរតែឥឡូវយើងរើសថាដោយសារតែ network partition កើតឡើងមានន័យថា P នេះវាកើតឡើងហើយឥឡូវយើងសួរសំណួរថាយើងចង់បាន consistent ឥឡូវធ្វើម៉េចឲ្យអា system ហ្នឹងវា consistent ទៀតបើទោះបីជា network partition ហើយវានៅតែ consistent ទៀតអញ្ចឹងបានន័យថាយើងចង់រើស C ហើយនិង P នេះអញ្ចឹងបើយើងរើស C និង P ហ្នឹងវា2បាត់ហើយតោះណាចា A នេះយើងត្រូវធ្វើម៉េចដឹងអត់
dương ở châu Việt.
Hả? Thôi vậy thử tại sao tao anh mình.
Dương ở châu Việt mình châu.
Nó là dương ở châu Việt, dương có bật châu Việt. Toàn đấy. Okay, so now maybe I can throw something. Okay, so let's say we have 5 computer, okay? And after that, the 5 computer has network partition. Okay, so in Cap theory, we said that there are 3 things. We have a consistency, availability, and partition tolerant. Okay, so now the network is partition, so which means that P is already occur. So now there is two things that we need to consider. Do you consider to choose availability or you consider to choose consistency? So if you want to choose consistency, which means you choose C and P, okay, C and P. And then, as I said, in CAP theory, you can choose only 2, not 3, okay? So if you choose C and P, you need to give up A, okay? So if you choose C and A, consistency and availability, it is already 2, you need to give up not C and A, okay? Availability and network partition, okay? So if you choose these two, you need to give up consistency. Understand? យល់អត់ឡើយហ្នឹងបានន័យថា capture គេនិយាយថាយើងអាចរើសបានតែ2ក្នុង distributed system គឺយើងមិនអាចរើសបាន3ហ្នឹងឯងបានតែ2ក្នុងចំណោម3ហ្នឹងឯងអញ្ចឹងបើសិនជាយើងរើស2គឺត្រូវតែអត់មួយហើយរើស consistency ជាមួយ network partition គឺអត់ availability ហើយតទៅពេលរើស availability ជាមួយនឹង network partition គឺច្បាស់ជាអត់ consistency ហើយអូខេអញ្ចឹងកន្លែងហ្នឹងឲ្យយល់កន្លែងហ្នឹងសិន okay, so now you choose C and P. You choose a network partition, so it is partition already. You choose consistency. So when you want to choose consistency, you need to give up availability. Okay, so you need to give up availability. So now there is one user is coming, and then one user want to access to the data. Okay, because the network is partitioning now, so user want to access to the data. For example, like here, x is equal to 2, and then here is x is equal to 3. Do you allow user to see the data of the x? The question is, do you allow user to see the data of the x, the value of the x? អញ្ចឹងសំណួរសួរថាឥឡូវមាន2 user access មក system របស់យើងហើយ So here is the whole system, okay, our whole system. But now we have 2 users, one user access to this computer and one user access to this computer. If they access, they will see the result x is equal to 3 here, x is equal to 2 here. So do you allow them to see the result? តើយើងឲ្យ user នឹងមើល result នឹងអត់ Yes or no? Do you allow A and B to see the result? Yes or no? The answer is only 2. Yes or no?
No, teacher.
Okay. So there's 2 answers, yes and no, okay? So if you say no, which means you give up availability, which means that your system is now not available, okay? If you don't give the answer to the user don't see anything. So user don't see x is equal to 2, x is equal to 3, which means that your consistency is still maintained, but you lost availability. តន់ឡើយហ្នឹងអត់មានន័យថាបើយើងរើសយក consistency មានន័យថាបើសិន user សុំមើលថាឥឡូវ data ស្មើប៉ុន្មានហើយគឺយើងអត់ប្រាប់ហ្មងតើណានៅពេលដែលយើងអត់ប្រាប់មានន័យថា system យើង down ហើយអញ្ចឹងបើសិនជា system យើង down មានន័យថាម៉េចគឺយើង give up available ហើយយល់ទេ For example, like when you access to your Facebook, and then sometimes they say that the website is on maintenance, please come back later. Okay, so in this case, our system give up availability, which means user cannot access. But you can maintain consistency because now when the network is not partitioning anymore, and then you update the system, and now the system is number 3. So when they access again, now you give them. Okay, so now everyone see x is equal to 3. Understand? យល់ឡើយហ្នឹងអត់ចឹងមិញមិត្តភ័ក្ដិយើងសួរថាបើសិនជាវា network ដាច់ partition ចឹងហើយយើងធ្វើម៉េចយើង maintain a consistency បានចម្លើយគឺអត់ឲ្យវាមើល data បានន័យថាសុកចិត្តប្រាប់គេថា system ខ្ញុំ down ហើយចាំ network ដើរស្រួលវិញចាំមកមើលតើណាអញ្ចឹងពេលហ្នឹងគឺយើងអត់បាត់ consistency ទេ Understand? តើអត់យល់ Yes no okay
យល់ច្រើន
Okay. Now the other thing. Okay, so let change to another one. So now I don't choose consistency, but I want to choose availability. And then I don't want to choose availability, consistency. Okay, so what will happen? So now the same thing. There is one user is want to access to the data. Okay, from this computer and from this computer, and then this one is x equal to 3, and then this one is is equal to 2. So we have the same thing. We have two users, A and B. So now the web network partitioning is happening, which means P is happening. And then we want availability, but we don't want consistency. So now when two users A and B want to access to the system, do you allow them or not? Yes or no? បានន័យថាឥឡូវវាមាន network partition កើតឡើងហើយមួយទៅយើងចង់បាន availability យើងចង់ give up consistency ហើយអាកន្លែងនេះគឺ x ស្មើ3អានេះ x ស្មើ2ឥឡូវមាន user access មកហើយមួយ access មកកាន់ computer ដែលនៅផ្នែកខាងនេះមួយទៀត access មកកាន់ computer ដែលនៅផ្នែកខាងនេះសួរថាតើយើងឲ្យ2នាក់ហ្នឹងចូលមើល data បានអត់យើងឲ្យ data ហ្នឹងទៅ2នាក់ហ្នឹងវិញបានអត់ Do you provide the data to the two user when we have network partitioning and then when we want availability property Yes or no?
Yes.
ពេលប្រឡងដាក់សំណួរចឹងហើយសួរចម្លើយវាពីរបើមិន yes គឺ no បើមិន no គឺ yes 50%អូខេ yes or no មិនមានម្នាក់ឆ្លើយថា yes ហើយចឹងអ្នកផ្សេងទៀត Yes or no We want partition tolerance we want availability but we give up consistency so now when two users access to the computer which already partitioned and then they have different data do you give the data to them when the user requests do you respond to the user yes or no
Yes.
Yeah the answer is yes why yes because we choose available if you don't give that means your system is not available okay but now your system is not down even the network is partitioning but your service is still running 24 hours or 24 hour or like 7 hours 7 days per 7 day so user B will receive the data 3 and user 2 will user A will receive the data 2 but in this case even the data is different it is not a big deal for example just like I said Facebook like okay for Facebook like so when one people access to Cambodia and they see that oh there is 2 like in this post and then the other people access to United States website and then they see that oh this post has 3 like so is it different between 2 like and 3 like or between 2 like and 10 like is it different so in one computer you see there is only 2 like another computer you see it is 10 like so is it a problem ចឹងឧទាហរណ៍ដោយ Facebook Live ចឹងមានន័យថាបើយើងបើក computer យើងនៅខ្មែរទៅស្រាប់តែឃើញ post នោះ post ជាមួយគ្នា post តែមួយទេតែយើងឃើញ like មានតែ2ទេតទៅពេលអ្នកផ្សេងទៀតបើកមើល computer អាមេរិកឃើញ post នោះមាន10 like សួរថាតើអាហ្នឹងបញ្ហាអត់បញ្ហាធំដុំអត់ Hello យើងមើល post មួយស្រាប់តែ post មួយឃើញ2 like post មួយទៀតឃើញ10 like សួរថាអាហ្នឹងជាបញ្ហាចោតទេ Is that the real problem
It's not really a problem.
Yeah, it is not a problem. It is a problem, but it's not a big problem. Okay, so in this case, we can give up our consistency. Okay, that means the system choose only network partition, and then when the user requests to the system, they provide the answer, even the answer is not the same. So we give up consistency, which means the answer is not the same. So one see two like, and the others one see 10 like, but this problem is not a big deal. Okay, so that's why we can give up our consistency. But for example, like this not two like or 10 like. These are the money. For example, like now I have $3 in my bank account, and now I have $2 in my bank account. So when I want to withdraw money or something like that, should I allow? I should not allow. So which means I should give up my availability, and then I should choose consistency. Okay. So it depends on the use case. Some use case you can choose AP like available and partition, and some use case you can choose consistency and network partitioning. Okay, so that's why in capsule theory we said that you can choose only 2, not 3. Okay, and it is possible because some use case you can choose the other 2, another use case you can choose another 2. So can you understand now what is the capsule theory about? Capsule theorem about? ចឹង capsule theorem ហ្នឹងគឺយើងចង់និយាយពីរឿង3យ៉ាងហ្នឹងមានន័យថារឿង3យ៉ាងហ្នឹងក៏ប៉ុន្តែក្នុងពេលតែមួយ distributed system ឈូសបានតែ2ឯងហើយដូចយើងមិញយើងឲ្យឧទាហរណ៍វាតាក់ទងជាមួយនឹងរឿង availability and consistency. So some use case we can choose consistency and give up availability, and some use case you can give up availability and choose consistency, something like that. So it is depend on the use case. Okay, so when you build your system, it depends on the use case. So sometimes you allow people to access, sometimes you just say that, okay, so now the website is maintenance and then come back later, because when you realize that your system has some partitioning happening, so you don't allow people to access to the data. Okay, so you choose consistency but you give up availability. Question, any question about cap theorem? ច្បាស់នៅប៉ុណ្ណឹង បានន័យថា cap theorem គឺគេនិយាយថា distributed system ទោះយ៉ាងណាក៏ដោយมันអាចមាន3នឹងក្នុងពេលតែមួយឯងច្បាស់ជាត្រូវលះបង់មួយចោលហើយក៏ប៉ុន្តែយើងអាចលះបង់មួយណាក៏បានដែរអាស្រ័យទៅតាម use case តោះណា use case ខ្លះអាចលះបង់រឿងមួយបាន use case ខ្លះអាចលះបង់រឿងមួយទៀតបាន understand okay I think our lesson is finished now. Any question, any other question?
Yes, sir. A question.
អស់មានអត់មាន question អត់ទេ
Yes, sir. House.
Okay, house សួរមកចឹង
Can speak ខ្មែរចា
ហ្នឹងហើយសួរមក
align consistency ចា have different database but store the same data អញ្ចឹងវាធ្វើឲ្យហ្នឹងវាទៅពេលយើង request វាទៅវាមិន slow មិនអីចាព្រោះវាមាន data គ្រប់ទាំងអស់នៅក្នុង database មួយអញ្ចឹងចា
slow មិនអត់យល់
អា database ហ្នឹងវាយ៉ាប់ request អញ្ចឹងចាព្រោះវាមាន data ច្រើននៅក្នុង database មួយអីចឹងចា
Okay. Okay, so the question is, he said that now we have a lot of database, okay? And then now all the database are the same, okay? Because we said that it is consistent. So it is consistent mean it has the same database, okay? But for example, like now your system is very big. And then your database is very big also, okay? So if this database is very big, this also big, and this also big. Okay, a lot of data here. So when you request to the data, is it slow or not? The question is like this, okay? Is it slow or not? For example, like I want to request user, okay? I want to request user, and then this database has like 1 million user. So when you request user, it will return 1 million user coming, okay? So is it slow or not? ចឹងសំណួរមិញមិត្តភ័ក្ដិយើងសួរថា database យើងវាមានច្រើនមែនក៏ប៉ុន្តែក្នុង database មួយនោះវា stock ស្អីទាំងអស់វាអត់បែងចែកទេតោះណាហើយចឹងពេលដែលយើង request ទៅវាមិន slow តោះណាឧទាហរណ៍យើងចង់ request user ស្រាប់តែ user ក្នុង database នោះមាន 1 million user ចឹងវាត្រូវ return 1 million user មកសួរថា slow អត់វាត្រូវ slow អត់ So when you develop a website and then when your system has 1 million user, for example, like ITC has 1 million student, and then there is some web browser request user want to list all the 1 million user, and then your database need to return 1 million user, okay? So now your system is very slow. So how can you solve this problem? How can you solve this problem? Because you don't separate your table. For example, like sometimes you separate your table, like a few data is here, a few data is here, but now all your database is here. So how can you solve the problem? មានណាគេចង់ឆ្លើយអត់ database យើងស្រាប់មាន 1 million user ហើយដល់ពេលគេ request មកទាំង 1 million វាមិន slow អាហ្នឹងគួរសួរមកគ្រូ database
ចាអញ្ចឹងមិនដឹងថា data នៅក្នុង database ហ្នឹងដូចគ្នាទាំងអស់ដែរ
ដូចគ្នាទាំងអស់
អញ្ចឹងមិនបែងចែកគ្នាទៅ1 million user ហ្នឹងបែងចែកទៅជា3ផ្នែកទៅគេថាបើកន្លែងនេះ level ខ្លះអាចទៅខាង database ផ្សេងទៀត
Okay, so ឥឡូវមានចម្លើយណា So now we have one answer from our friend. So solution 1, he said that we might separate our data, okay? So solution 1, we might separate our data. For example, like in database today, there is also something like this. So for example, like from user 1 to user, like we can say, okay, 5,000. From user 1 to user 5,000, I store here. From 5,001 to like 10,000, I store here, and from 10,000 to 10 million, I store here. Something like that. So in this case, when for example, like when we want to request user which is located in at this table, between this ID, we can request to this database. So when the user ID is between this table, we request to this database. Okay, and then when we want to the user ID is in this database, we request to this database. So in this case, you can see that the data is not located at the same place. So we said that distributed system or the database are the same. Okay, but when the data is big, we can separate it into different database. So depend on their ID. So when the user requests the people among within this ID, we need to request from this database so that our system is getting better. Okay, but for example, like as I said, if we separate database and all the database are not the same, when this database broken, what will happen? ចឹងមិញគ្នាយើងនិយាយថាដើម្បីឲ្យវា slow យើងបែងចែក user ហ្នឹងកុំដាក់នៅវានៅមួយកន្លែងយើងទុកខ្លះណានេះទុកខ្លះណានេះទុកខ្លះណានេះចឹងទៅអូខេឥឡូវមានបញ្ហាចុះបាទមួយនេះវាមាន problem មានរឿងកើតឡើង Now what happened when this database is down? If this database is down, you lose all the user with ID 1 to 5,000. Okay, so to solve this problem in the distributed system, you need to have at least a backup. Okay, so 1 to 5,000 is located at this machine, and then it also located at this machine. So now you have 6 database, but 2 database are the same. Okay, these 2 are the same, these 2 are the same, these 2 are the same. So when one go down, at least you have one more, and then you can restore this one to this one when it is coming back. តោះនៅប៉ុណ្ណឹង ចឹងបានន័យថារបៀបយើងធ្វើឲ្យ system យើងដើរលឿនវាមានច្រើនណាស់មានន័យថាបើសិនជា data ហ្នឹងវាកាន់តែច្រើនទៅវាពិតជា slow មែនហើយក៏ប៉ុន្តែ solution ក៏វាមានដែរគឺយើងបែងចែក data ហ្នឹងកុំឲ្យវានៅមួយកន្លែងហ្នឹងវាឲ្យវានៅច្រើនកន្លែងទៅក៏ប៉ុន្តែនៅពេលដែលវាមាននៅច្រើនកន្លែងហ្នឹងបើសិនវាមានតែមួយទេវានៅតែ single point of failure ដដែលទេតោះណាចឹងបានន័យថាបើសិនជាអាមួយហ្នឹងបាត់ user ID ពី1ទៅ 5000 ហ្នឹងគឺបាត់ហើយព្រោះ data ហ្នឹងខ្ទេចបាត់ហើយហ្នឹងហើយអាពីរនេះវាអត់មានផងហ្នឹងចឹងដើម្បីឲ្យវា backup បានឬមួយក៏ distributed system បានតើតែយើងមានអា system ហ្នឹងយ៉ាងតិចក៏វា2ដែរតោះណាបានន័យថាបើសិនជាអាមួយនេះខ្ទេចយើងអាចយក recover ពីអាមួយនេះមកវិញបានតោះណាវាមិនតែ system ក្នុងពេលតែមួយខ្ទេច2ទេតោះណាបើខ្ទេច2យើងដាក់3មកអូខេចឹងក្នុងករណីហ្នឹង system យើងគឺវាលឿនជាងមុនហើយក៏វានៅ maintain អា distributed way ដែរតោះនៅប៉ុណ្ណឹង Did I answer your question? So
Yes,
when
sir.
when the data is big, you can split, but at the same time you need to back up. If you don't back up, it is still a single point of failure. Okay, but now you can improve your performance because in order to request 1 million, now you only request a few. Okay, and the other thing is pagination. Okay, pagination. So what is pagination mean? Mình là cái đăng áp cái pagination. So when you request the data, you don't request all. Okay, you request only one page, and then when user click on another page or scroll down, you request more. Okay, at that time you can also slow down the speed of downloading the data. តោះណាបានន័យថាធម្មតាមនុស្សយើងមិនតែមើលម្ដងឃើញមួយលាន user អញ្ចឹងទេយើងមើលម្ដងឃើញតែមួយ screen ទេតោះណាអញ្ចឹងយើង download ម្ដងមួយ screen មកឬមួយក៏ម្ដងមួយ page មកនៅពេលដែល user ចុចមួយ page ទៀតចាំ download មួយ page ទៀតមកអាហ្នឹងក៏វាធ្វើឲ្យ system យើងដើរលឿនដែរអូខេអាហ្នឹង solution ដែរ Okay, so now you have another 30 minutes. I think it is the end of our theory, and if you have any question, you can ask now, or otherwise we can go to our practice. So any other question related to our today topic? មានសំណួរផ្សេងទៀតទេ Any other question?
ឈើពីមកគួរឲ្យមុនខ្ញុំមកបានចូលអញ្ចឹងបើឈើឲ្យ install យកបន្ទោះប៉ុន្តែខ្ញុំអាចប្រើ VMware បានអត់បានប្រើអីក៏បានដែរឲ្យតែមានយូរបន្ទោះឬមួយក៏យើងចង់ប្រើ Mac ក៏បានដែរឲ្យតែយើងចេះបានន័យថា install software ស្អីខ្លួនឯងព្រោះអីយើងឲ្យតែ software ហ្នឹងវាមាននៅក្នុងម៉ាស៊ីនរបស់យើងហើយយើងប្រើបានគ្រាន់តែពេលខ្លះវាមាន comment ខុសគ្នាតិចតួចទេតែឲ្យតែយើងចេះប្រើអាហ្នឹងអត់អីទេ So in terms of application, you can choose any application, okay? Even operating system, Windows, Linux, or MacBook. But the problem is we may have some different type of command in order to install. But normally for the technology is the same, okay? When we type the technology or using the technology is the same. Only the difference is how to install it, how to configure it, okay?
choose whatever operating system or technology you want. Any other question មានសំណួរផ្សេងទៀតអត់ថ្ងៃហ្នឹងសង្ស័យអត់បាន record ទេនេះម៉ោងយើងចាំម៉ោងក្រោយចាំ record. Any other question?
No, teacher.
Okay, so now we can have a 30 minutes. If you have your computer, you can if you have installed, you can install it, or otherwise you can install it after the class. So today, if you see these two videos, the first video is talking about how to build a simple distributed system, and then he also provides some code. So the code is in this GitHub, okay? And then the other video is he's talking about 1 hour distributed system, and normally he talking about the difficulty of creating the distributed system. So when you see these two videos, you can have a more understanding of what is the distributed system is, and is it easy or is it hard, okay? So normally when you go from centralized to distributed system, it's very hard. So you need to like work harder than the normal system, okay? So now you can if you have already watched it is good, and after that we want to implement the code that he has provided to us. So now I have opened my Ubuntu. If you have opened your own Ubuntu, it's okay. So here is a virtual box. I install my Ubuntu here. As you can see that now I have a 4 system. So I also install Kali Linux here. Kali Linux is an operating system used for security and hacking, something like that. And then I also have another operating system here. So I already open it. So everyone can use Ubuntu or not? ចេះប្រើ Ubuntu គ្រប់គ្នាទេចេះ download មក download មក install អីបានអត់ Everyone can use Ubuntu. I think for the installation you can search. There are plenty of documentation online like Google or YouTube how to install, how to whatever. So normally Ubuntu is an operating system, okay? So I think in year 4 you also have the operating system class in first semester and second semester, so that you can know something related to Ubuntu. Or if you are not aware of it, you use a Mac or Windows, the same thing. Windows has PowerShell and Mac has also terminal, okay? So in Ubuntu we have the terminal also. So terminal normally we can use we can write the command, okay? And after that I create a folder. So normally my folder is here, okay? So how do we create the folder? What are the commands to create a folder? Anyone know? If I want to create one folder, what should I do?
Use the command mkd.
Okay, so now if I want to go to desktop, what should I do? Now I am at home directory. I want to go to desktop. What should I do?
cd desktop.
cd desktop. Okay, so now I am on desktop. So now I want to create one folder on desktop. mkd, and then maybe we call it a distributed system. Okay, ds or distributed system. Okay, so now I create one folder here. Okay, you can see here this is the folder. Now I want to enter to the folder cd distributed system. Okay, so now I'm here, and then my folder is empty. Okay, so now I want to clone the code from his website here into my computer. So what should I do?
Run.
Okay, so I will open the internet inside my virtual machine, and then I want to search for his GitHub, and then what is the name? Goldfire. Okay, so I just search GitHub, and Goldfire is the name of his company. So here is his GitHub, and then in his GitHub he has a lot of projects. So you can see that he has a lot of projects, and the project that we are interested is not here. Let me see. Where is the SOMO? Here is the library that he created, democracy.js. But we want to search for the other repository. So he has a 31 project, and then the project that we are interested one is this one, building distributed system with Node.js. Okay, So here is the link of his project. Normally you can click on download, or if it is possible, we can copy this one and then we can clone it in our code. Okay. So we can use git clone and then the URL. So now we already clone. So ដើម្បី download code បានគឺយើងប្រើ git clone ហ្នឹងទៅហើយនឹង URL របស់វាហ្នឹង so when you open here you can see all these are his folder. We can also check ls, so cd build distributed system. Okay, so inside this project you have a source. I think source he has a production and version 1, version 2, version 6, version 4, something like that. But inside here you can see that he has an index file which is a client file. He also has a server which is a Node.js server, and he also has a HA proxy which is a proxy. Okay, so if you go to the YouTube video you can see that the system is normally he create a simple distributed system. The system has 3 nodes. Okay, 3 computer, and then in order for 3 computer to work together, he used another system called proxy. Okay, so HA proxy is this one. This one is HA proxy. HA proxy. Okay. So what is HA proxy mean? HA proxy mean is just like a gateway or a proxy. So when you have one user, and when any user connected to this proxy, it will redirect. For example, like one user come, it will go, okay, you go to this server. Okay, so another user come, okay, you go to this server. Another user come, you go to this server. Okay, and another user come, okay, now you go to this server. Okay, so HA proxy is just a system that redirect the request to the server. So for example, like now there is a lot of client coming, and then this server are very busy. Okay, so now this server are very busy. So HA proxy will redirect the request to the proxy to the server that are less busy. Okay, so that is the role of the HA proxy. So we have HA proxy, we have server, so we can see that in the computer we can run a lot of server. So the server name in the code is he write in the file called server.js. Okay, so server.js mean each server has a server.js. We can run the server.js, and all the server need to communicate with each other. So there is another program, we call it a messaging program. So in order for all the server to talk to each other, there is another program. Okay, and that program is called messaging program, message passing. So in distributed system, we say that it is a message passing program. Okay, there are a lot of message passing program. So in this case, he write his own message passing program, which is called democracy.js. Democracy, you can see the democracy.js. Okay, but we can choose use another program. There are a lot of programs. For example, like we have Zero MQ, we have a Rabbit MQ. Okay, so there are a lot of programs, but to him, he create his own program called democracy.js, which is used to communicate with all the nodes communicate with each other. Okay. អញ្ចឹងបើសិនជាយើងអត់ច្បាស់ទេយើងអាចទៅមើលវីដេអូ YouTube គាត់ទៅគាត់បញ្យល់បានច្រើនណា So now we have a server, so here's our server, and then we also have our HA proxy configuration, and then we also have our client here. Okay, so in order to run this application, you need to install Node. Okay, normally if I write here Node version, you can see that my Node is version 12.20. But if you don't install Node in your Ubuntu yet, your computer may not understand the command Node. Okay, so in order to use his program, you need to install Node also. You also need to install HA proxy. Okay, because otherwise you cannot run the command HA proxy. Okay. Okay, so now let's go to see the server, what are written in the server. And also normally I use the text editor. My text editor is gedit. You can also use a Vim or VI or Nano, it depends on you. So those are also the text editor, but normally I use a gedit for interface, and then I can open the server to see how it works. You can also install Visual Studio Code to open it more in a programming way, okay? So here is a server, and then here's the code of the server, okay? So now you can see that he used a democracy, which is a democracy JS that he has written, and then he used a WebSocket for communication, and then he has a two server, so like a 3000 and 3001, okay? Maybe I can write another server, like if I have three server, I can have 3000, 3002. Okay. So in this code, which means that the program has a normally, for example, like server one, he has a IP. We can write any IP. So 000 means any IP, but normally we use our local host. So 3000 is a port. Okay. So in this case, we have our own port. So the port is used in the we call a parameter, and after that the peer is about the computer of a related peer. So as you can see that we have a computer, for example, like this one is computer number one, but they have their own peer like number two, number three, something like that. Okay, so that are the code inside the server. We can run the server now. For example, like the server is listening to port 3000, so I can run node server.js and then the port 3000. Because when you see the code, I can open the code again. So the server is listening to port 3000, and then this port need to put from the argument. Okay, so that's why we need to put the 3000 here. So now I run my first server. Okay, so there's some error. Oh, Primus. Let me check again. I think I installed the Primus. Maybe I run it before I run the proxy. Or okay, I forget because I create a new folder. So now when anybody can tell me why there's an error here? Why we have an error? មានអ្នកគេដឹងថាហេតុអីបាន error នេះព្រោះខ្ញុំបង្កើត folder ថ្មី Anyone know why is an error? So what is the error about? ដឹងថា error នឹងបញ្ហាគេ in on Tuesday I told you that whenever we have some error, what should you do? Hello. ងាត់ឆឹងចឹង
We can search.
Yeah, we can search, but we also before search we need to see the message error. Okay, you can see that here the message error is that cannot find the module Primus. Why this error? Because in the server we require a library called a Primus. Okay, and after that I haven't installed that library yet. Why? Because now I'm not using my old directory. I'm creating a new folder, and then this folder has not installed all the dependency of the code that I'm using in my server. Okay, so here my server need the library called democracy, need the library called Primus, and maybe need another library. So normally in the Node program, all the dependency is in the package.json file. Okay. So when you go to package.json, in order to run this server, you need submono, you need WebSocket, you need Primus, you need democracy, but I haven't installed it yet. Okay, because I am just create a new folder. So before we run our server, we need to install all the dependency of the Node library. So how do we do it? How do we do it? How to install the library? មានអ្នកគេធ្លាប់ប្រើ Node អត់ដែលបង្កើត website ដោយប្រើ Node.js អត់ So now how do we install those library? So now we have a package.json here, and then it needs a lot of library, but I don't have it in my computer yet, in this folder yet. Okay, so we just write command npm install. Okay, because we have an normally if you create a new library, we type npm init. Okay, but now as the library is already cloned here and we already have package.json here, so we just write npm install, which is used to install the library of the Node.js. Okay, so now it start to download all the library that we are need, like a subdomo, Primus, WebSocket, or whatever. And now let's try to run our server again. So if we want to run server in Node, we just write Node and then server, the name of the file, and then a port because we need some port. So as we can see here, so here the port is choosing from the argument, and then after that it will put it here. Okay, port 3000. So now you can see that there's no more error, and then my server is running on port 3000. Okay, so when you go to client, if you go to for example like localhost 3000, and then when I enter, normally it will show the message it work, but actually in the YouTube video he shows step by step for you in order for you to understand. But in order to run this server, because now we already using the HA proxy, so we need to run the proxy first before we run the server. But when I test when I run this it work, but now it doesn't work. But we can also run HA proxy first. So HA proxy is the file that we use to in order to load balancing. Okay, so HA proxy is here. Okay, I think in my old folder, because here is the folder that I create. I can open my folder. Okay, so in order to run the HA proxy, these are the command. Okay, HA.f the configuration of the HA proxy. But before running the HA proxy, you need to install the HA proxy in your machine. For example, like Ubuntu, we say sudo apt-get install, and then we need to also configure one configuration file in the etc directory. Okay, for example, like here I can show now gedit and then at etc / default / proxy HA proxy. Okay, so in this configuration file you need to add this line. Okay, enable 1, otherwise it doesn't work. And after that you can run your command from here. Okay, HA proxy config copy. Okay, so now I may try to run in my folder if it works. Okay, so here is the HA proxy. It is a load balancing. So when you run this one, which means you run this part of the program. Okay, now the program is working. You need to run another server, for example, like a 1 or 2 or 3 server. Okay, so let me try to run some server. Okay, CD. Let's choose the new one, the desktop one, and then it is called distributed system. And then I go to this folder. I run the server node server port 3000. Okay, and after that I may try to run another server called server 2. So these are the server 1, and then I may try to run another one, desktop distributed system node server port 3001. Okay, so now I have 2 servers running. So in order to run the client, normally in the folder you can see that there is an index file. Okay, the index.html. We can go to see that file. Okay, so when you go to when I open this index file, you can see that the client, so index file is just like a client. So in terms of this diagram, here is an index.html, and then when it connect to an HA proxy, it linked to the first server. So that's why in the terminal here you can see that the client is connecting with the port 3000, but not this one. Okay, so here is a client number 1. Okay, so maybe I can run another one. Maybe I can open with a new browser. Is it possible? Yes, it is possible. And you can see that now the second client is go to the second server. Okay, so where is the, okay, so now we have two clients. Okay, you can see these are the first client, and then these are the second client. Okay, so the second client is go to server number 2. So that is why we call the HA proxy is a load balancing, because it redirect the request to the other server. Okay, so let's try to open a new server. For example, like now I not having 2 server, but I have 3 server. Okay, CD desktop, demo distributed system, and then build, and then I run another server, node server port 3002. Okay, so now we have 3 server running, and then when I want to create a new client, so now I have 2 clients, but I want to create another one. So let's see this client go to which server. Okay, so now the third client is go to the first server. You can see that now the first server has 2 client. Okay, it can receive another client. So if a new client coming, it go to the second server, and maybe another server coming. Let's see another client coming. If I open another one, okay, it go to the first server again. So it did not go to the second server. Maybe the code. I think the code I include already. Let's see the code server. Okay, yeah, the code is including server 1, server 2, but server 3, maybe the configuration file hasn't included server 3 yet. Okay, yes, it's true, because default in the HA proxy only have 2 servers, so maybe I can add another server here so that it can redirect the request to the third server. 1.7.0.0.1, and then port number 2. Okay, check. Okay, so I can take down all the server. So we have 3 server, and then these are the HA proxy. I can take it down and restart again, and all my client close. So now let's restart the HA proxy. Okay, so now HA proxy is start, close it. I will start my server again. Okay, so now these are the server number 1 in port 3000. These are the server number 2, node server port 3001. And then these are the server number 3, node server port 3002. Okay, so now we have 3 server running. So when the client coming, okay, so the first client is connected to the server number 1. So when I have another client coming, it connected to server number 2. And then when I click another client, it may go to the server number 3. You can see here. If I click another one, server client number 4, it go to the server number 1. Okay, so HA proxy allow the request to separate to many server. Okay, so you can see that the client is working. Okay, it's working. So now when some server is going down, for example, like now I kill the first server. Okay, now the server is going down. Now we only have 2 server. Will the client still working? Okay, so you can see that the client, yeah, the client is still working. See, the client is still working, because our system is a distributed system. Even if one server is going down, the system is still working. Even if I kill another server, for example, like now I kill server number 3. Okay, I kill this server. Control C, we can Control C. So now the server is down. No, so now our 3 server has only 1 server is running. Okay, so all the 4 clients are connected to this server. You can see that the HA proxy redirect all the client to this server. So even if our 2 server is down, we still have 1 server, and our system is still running. Okay, so if I go to my client, so you see that my client is still working. See, all my clients are still working. And then the server can come anytime. So when we restore our server, because now our server has only 1, we need to back up our server back. we need to make our server work. So desktop distributed system build, and then I run my server back, for example, like server number 1, say port 3000. Okay. So now my first server is coming back. So now we have 2 servers. Okay. So when a new client is coming, it can go to the new server. Okay. Because now the server has only 4 clients, and the client will go to another server. So if I run another client, which server it do it go? So you can see that this has 4 clients. So when the new two client coming, it all go to the first server, because the HA proxy may redirect to the client which has the less request. Okay, you can see that in the configuration, you can see that here the configuration list connection mean it will redirect the client to the server which has less connection. Okay. So at home, you can try to run it, install it, and then try to understand the code. And maybe during the other TP, I will explain more like how to create a server, how does the code work, because sometimes you don't know how to write the code in Node.js or in Express. I will explain it more, but the idea of today is to understand how the distributed system work, how the simple work by using only a few programming language like Node.js, HA proxy, something like that. Okay. Any question about this? So you can try at home. So in order to run this code, first you need to download the code from GitHub. Second thing, you need to you need to install Node in your machine. Okay, you need to search on Google how to install Node in the machine, Node here, because otherwise you cannot run the command Node server like this. Okay, because your operating system doesn't know Node. So you need to install Node, and you also need to install HA proxy. Okay, HA proxy. Okay, so when you install Node HA proxy, you are ready to run this application. Okay. Còn ấy, vô lấy.
Chờ chờ khi chờ mình ra nè comment anh bấm install là nó comment nó cái đào mình.
Okay, so the question is why I run npm install. Okay, let me close everything. Okay, so for example, like here is the file that we download from GitHub, and then normally in the Node programming, Node is a JavaScript. In order to run the code, for example, like our server, you need some library. So these are the library that you import from somebody else. It is not from you. For example, like democracy is written by a Godfire. Okay, so normally our system don't know this library. They don't install yet. So in order to install this one, in Node, we write all the dependency in a file called package.json. Okay, so when you go to package.json, you can see that these are the dependency which you list all the library that you are using. For example, like now you are using subdomo, WS, Primus, democracy. Sometimes, for example, like if you use Express, you can import here, like for example, like Express. Okay, something like that. And then now the computer doesn't know the library yet. Okay, so in order to install all this library, you need to run the command npm install with this directory. Okay, so you need to go to the terminal. Okay, cd, for example, like cd desktop. So inside desktop, we have our library called our folder. This is distributed system, and then these are the program that we download from GitHub. So in here, you can see that in here. So in here, we have a file package.json. So if you have package.json here like this, you can run npm install. So this command will install all the library that mentioned in the package.json. Understand?
Mình nói comment thằng ran mát to là dân miền package.json xin mẹ.
Yeah, vì to tại dân miền package.json hay to tại dân miền miền môi tiết cứ miền này npm này. So in order to use Node, you need to install also npm. npm is a network package manager. Okay. So for example, like now we can search in Google how to install npm in Ubuntu, something like that. Okay, Ubuntu. Okay. So in order to install npm in Ubuntu, so here are some command line, but you can also using here, okay? Node app install Node.js. So here they install Node.js, and then here are some dependency. So the dep is a Ubuntu package that you can install. Okay, so here is an npm. Here is a node how to install node in Ubuntu, and this one is a how to install nvm. So in node we have nvm and npm. Okay, so nvm is a node version manager, and npm is a node package manager. Okay, so when you install this one, you can use it. I think maybe when you install node, you already have npm. Okay, nvm is another thing. Yeah, so just look at this one, and then you can install nvm is also useful when we are using Node, because when our computer has different version of Node, we can use nvm to change the version. Okay, so when you install Node.js, I think npm is also installed. Okay, for example, like now I have a new I want to create a new project. Okay, so now these are the project that we just create, and then for example, like okay, dear my new project. Okay, my new project, and then I cd to my new project. You can see that the project is empty. Inside the project there's nothing. So when you want to create a Node project by yourself without cloning some code from somebody else, the first project the first command that you need to run is npm init/y. Okay, when you run this program, you can see that you have a package.json. Okay, these are the simple way of creating a Node program, and after that you start to create. For example, like I create my server.js file. So now you have server.js, and then I start to create another directory, something like that. Okay, so when you have a package.json, and then when you create a dependency like which library that you want to using, you can run npm install to install all the dependency. តោះណាចឹងអាហ្នឹងរបៀប use Node. Okay, so I think it's time, because maybe we have another class from 9. So if you have any question, you can ask in MS Team. Okay, I will answer that, and try to run this application at home. Okay, តោះវិជាមានអីចង់សួរ If not, we can finish our class, because it's time. You can try to run the application at home, and if you encounter some problem, you can write on the chat room in MS Team. Okay, តោះណាគេលើកដៃមិនមានសំណួរអត់បើអត់ទេយើងចាប់ប៉ុណ្្នឹងហើយ
ឥឡូវឈើលឺអត់
លើ
ខ្ញុំនៅពេលដែលខ្ញុំ install npm ហ្នឹងវាអត់ដែរហើយតែវាអត់ success យ៉ាងនេះច្រើន
អត់ success ប្រហែលជាចុះយើង install Node នៅនេះអា Node នេះ
អត់ហើយ
install Node ហើយតែ run npm អត់ដែរ
វាដើរមកពាក់កណ្ដាលហើយវាឲ្យយើងសួរ yes no ដល់ពេល
អាហ្នឹងមកពីយើងនេះយើងឆ្លើយ yes ទៅ
ហើយ yes ចូលមើលក្នុងឆាតផ្សេង
ហ្នឹងហើយចាំមើលមានបញ្ហាចាំខ្ញុំចូលមើលក្នុងឆាតអញ្ចឹងមានបញ្ហាយើងអាចវីដេអូឬមួយក៏ screenshot អីមកហើយចាំខ្ញុំឃើញចាំខ្ញុំប្រាប់ទៅវិញអូខេ
ខ្ញុំ screenshot ហើយ
ហ្នឹងហើយអូខេអញ្ចឹងវាដល់ម៉ោងដែរហើយអញ្ចឹងយើងសម្រាប់ប៉ុណ្្នឹងសិនទៅព្រោះវាដល់ម៉ោងត្រូវព្រានម៉ោងក្រោយទៀត Okay, so see you. If you have any question, just write in the MS Team or in chat here. I will answer next time. Okay. So see you. Bye bye.
Goodbye.
Goodbye.
Goodbye.